promises, async, and the event loop. Promises, the most significant ES6 feature added, I think in 2015. We'll see by the end of today that they're used to make our code far, hopefully easier to read, but if we don't understand how they're working under the hood, they are pretty magic, and maybe magic to a fault. So we're going to understand how they work under the hood. We're also actually going to see how to, something we'll do new in this hard parts, see how to take more control of our promises, not just send off some work to the internet and that's the end of the story, but even to abort those promises if we want to. We'll understand this architectural feature of JavaScript, asynchronous code execution. That's what makes dynamic web applications possible. We will then understand the event loop. This is JavaScript's effort to determine what to run next. It's triage. And to do all this, we'll have to understand the microtask queue, the callback queue, and our web browser APIs and features. But to begin, we need to remember how JavaScript code runs. And so we are going to have each person in the room verbalize a line of code for us. Woohoo! And so here we go. We remember when JavaScript starts running, all it does is create a new global execution context that comprises going through the code line by line, known as what? Who wants to tell me what going through the code line by line is known as? Joe, what's going through the code line by line known as?
A thread or?
Yeah, thread of execution, right? And does it, how many things can we do at once in JavaScript? How many things can that thread do at once?
One.
One, exactly, one. Well done, Michael. Well done, Joe. And then we also have the chance to save stuff in memory. So let's get going with that. Let's turn on JavaScript. As simple as that. And forgive me, my voice still seems to be holding up. And then we are going to open our memory, a place for us to store stuff. And we're going to hit our first line where, Chris, we are going to declare what into this memory?
We'll make a place for num.
Beautiful.
And we will put 3 in it.
That works for me. Declare a constant num and assign it the value of 3. To be honest, I don't mind the very, very intuitive take by Chris. Next line, Austin, what are we declaring?
Setting up a function.
Yep. By the name of what?
It's multiplied by 2.
Okay, so we are declaring a function multiplied by 2. Austin, say it again. We're declaring a function multiplied by 2. Well done, Austin. Excellent. Do we go inside the body of that function yet, Austin?
No.
No, our thread jumps straight down to what? Tenzin.
Goes straight down to declare output.
Yeah. Do we know what to assign to it yet?
Not yet, no.
No, because JavaScript has to do some work, which is the work of doing what? Yeah, keep going. Go ahead, Tenzin.
It creates an execution.
It creates, actually, hold on. So we got to call what function, Tenzin?
Call multiply by 2.
Multiply by 2.
With the argument num.
Which is going to evaluate to 3. And what tells us to call multiply by 2?
The parens.
Parens. And then, people, because it's the start of a new day, we're going to create a brand new, everyone together,
Execution context.
I hope you're all saying it online as well. Excellent, there it is. And into it we go. And I think it's worth now adding our third component of our JavaScript execution model, the place where code runs. And that is our call stack that is going to keep track of what function we're currently running. That is to say, where in our thread of execution we currently are. Now, we learned yesterday that doesn't always determine what data we had available to us, right? Our lexical scoping also helped with that, gave us closure, but we do know that it keeps track of where we're currently at in our code. As soon as we start running code, global is added, or it's always on the bottom of the execution context, on the bottom of the call stack, as long as we are running our JavaScript. But now we're running multiply by 2 with the input of 3, and so it gets added to the top of the call stack. Into it our thread weaves, where, Brady, what do we hit as the first thing inside of multiply by 2 for us to do in our local memory?
The variable input number is assigned to the value 3.
Absolutely, but what do we call our variable name when it's a placeholder as a input to a function? It's known as a parameter, and it's assigned to the value of 3, our argument. Excellent. Then we declare result, which will be the result of input number by 2, which is 6. We then hit the key word return that's going to grab the value of result, return it out into output. Beautiful. What happens to this execution context, Brady? Brady, what happens to this execution context?
It goes away.
It goes away. It gets popped off the call stack, removed from the call stack. Our first erase, which we love. There it is, off the call stack. And we hit global again because it's now top of the call stack. Our thread comes out. And Ryan, tell us what we do next.
Execute the...
Well, coming in a second, but first we declare...
Create a constant of new output.
Perfect, new output, to which we're going to assign what? Do we know yet?
No.
We don't. We've got to go and do some work because JavaScript never leaves any line unfinished. It never says do that work. Well, we'll see. So we're going to stay here and we're going to have to do some work, which is to call what function again?
Multiply by 2 and passing it the argument.
Beautiful. We invoke, we call, we execute, we run, multiply by 2 because we see parens on the end of it. We create everyone together a brand new
Execution context.
That's good. The people who keep the energy up on execution context are truly the gift to society. And into it we go, and we write local memory because I just love writing stuff on a blackboard. And in we go, and we assign to our parameter input number, our passed in argument, the value 10, and then we declare inside their result, which we assign the value of 10 by 2, which is 10's in our specialist. 20. Look at that. Amazing. And we hit the return statement, which says return out the value of result. So it says go find result, return it out into our global context where we assign it to what global constant, Ryan, again?
New output.
New output, beautiful. And that was back on the call stack as well. We popped it off. People, what do we notice here about our JavaScript code? Do we run multiply by 2 the first time at the same time as the second call of multiply by 2? No, absolutely not. People are shaking their heads. Exactly, we definitely don't. Because in JavaScript, we can only do, within our JavaScript land, one thing at a time. Did we hit the next line declaring const new output before we finish inside the execution context and multiply by 2 with the input of num that was 3? Did we hit that next line before we ran multiply by 2 the first time? No, we definitely did not. Firstly, well done everyone for walking through our code with clarity. This is our core JavaScript model. I am absolutely certain I do things line by line down the page. It is known as the thread of execution, doing the code line by line. How many threads of execution do I have in JavaScript directly? Everyone together?
1.
What? Yeah, well done, 1. Exactly. In fact, I had to use it to go inside multiply by 2 before I could get the return value and assign it to output. I did not hit multiply by 2 call and then go, do some more work while we're waiting on multiply by 2. You can probably see where I'm going with this. That's maybe a problem. Asynchronicity is the backbone of modern web development in JavaScript, and yet we've just seen it is single-threaded. One command runs at a time. It is run and executed synchronously. Each line is run in order the code appears. We didn't jump down to other bits before we did something else. Makes it super predictable. But what if we therefore had a task accessing TikTok? I chose a really who knows that by the time this goes live, this may no longer be accessing TikTok server. So that's not on our computer, it's somewhere else, to get new video links. That could take a long time. In the land of computing, that could take vastly longer than our entire application takes to execute its code. Maybe it takes 300 milliseconds, maybe it takes 100 milliseconds, but it's going to take time to go, which is remarkably short, of course, given it's speaking to a server in West Virginia, potentially, or wherever Oracle has put the... Anyway, who knows? But we also don't want to not do... We want to go and do that work because we want to work on that data. Maybe, for example, run some code displaying those videos once we have the data back. Challenge. We want to wait for the video links that we could then store back in JavaScript and then run some code on, but that would mean no code could run in the meantime. Let's have a look at some sort of dummy code, some kind of pretend code. Slow function blocks further code running because JavaScript is a single thread. Have a look at this code here. We're going to have our function get videos. It's going to head off to TikTok and get some videos from me, I suppose, maybe. It might take us, some time, 350 milliseconds, while that request is sent to TikTok. When the result comes back, we want to run a function display videos on that data. But we do need to wait for the videos to display them. But my lovely console log says, I want to run. Can it run in between? No, single thread. What if we try to delay our function directly using set timeout? So we declare a function print hello. We're then going to use this built-in function set timeout that is going to allow us to delay by 1,000 milliseconds the running of our print hello function. And we want to manually wait for our 1,000 milliseconds to pass. We have to do that, people, presumably we're having to do the counting, maybe some way in JavaScript, but I don't know, like some sort of count in JavaScript to wait time. Maybe we know how long a loop takes and we're going to wait that time. With that in mind, what will the console logs in our code here, what order will they log in? We have our declaring print hello. We're then setting a timeout that when it eventually finishes running will print hello, the console log hello inside print hello, and then we got our console log me first. I assume, well, let's see. What do we think? Matt, you're up. Matt, stop testing. Matt, what order do we think here? Okay, what order do you know these are actually going to? What order does my version say it should execute in here if we're in our single-threaded JavaScript environment?
I guess it would say hello first and then me first.
Right, because we've got to finish that line of code, the timeout, before we hit our me first. Is that what actually happens, Matt?
No.
No. Huh. Let's make it even odder. What if instead we delayed our print hello by 0 milliseconds? Matt, what order would my code imply that we would?
It would imply it would say hello and then me first.
Is that the actual order that would happen here?
No.
No. Our regular JavaScript model that we spent everything so far on is failing us. We're going to need to add some new pieces. JavaScript alone, this beautiful 3-part system, thread of execution, single, runs through the code line by line, memory, and the call stack tracking which function we're currently running is not going to be enough. We're going to have to add some other components. Our core JavaScript engine has 3 main parts: thread of execution, memory or posh word for a variable environment, or state, the data stored in our app at that moment, and our call stack. We have to add some new components, and that is what we're going to do. We're going to need to add web browser APIs. In Node, they're called background features or background APIs or Node APIs, promises, the event loop, callback or task queue, and also the micro task queue. These pieces are not going to be in JavaScript. They are instead going to be part of an outside system. JavaScript does not run in isolation. JavaScript instead runs where? Where, Tenzin, does JavaScript run?
The browser.
In the web browser, or within the Node environment, within the larger Node or computer environment. And it turns out that actually we have a whole bunch of additional features that are available to us in JavaScript from the web browser that are not actually in JavaScript. In fact, we're going to walk through this code here, but let's start by actually just even coming up with some of the features that are not in JavaScript. And I'm going to use blue from now on for my web browser. So we have our JavaScript. I'm going to put over here. We have our JavaScript engine with its big 3 things: our call stack, our thread of execution, our memory. And then we have in the web browser a whole bunch of additional features. Can anyone give me, raise your hand, give me some of the additional features? Yes, Michael.
We have the DOM.
The DOM. We have the DOM. That's probably in the top 2 most important. Right, that's the DOM is the bit that allows us to, is a model, the M stands for model, in an object format, it's a big old object, that describes what's on the actual web page so that we can interact with it. Beautiful. From within JavaScript. Huh. What's another one, Austin?
Service workers.
Service workers, absolutely. Austin's favorite. Service workers. I saw Matt, yes. Oh, sorry, Ryan.
Console.
Console. You show off. Exactly. Even our console, people, is not in JavaScript. Well done, Ryan. That's exactly right. Even our console is not in JavaScript. Our dev tools aren't in JavaScript. What else is? Yes, Michael.
So we'll set timeout and then also set interval.
Oh, so you're saying even potentially timers are not actually a JavaScript feature. Michael's right. Why are you stealing all my best ones? Excellent. Austin.
Fetch API.
Oh, speaking to the network. So network being the internet, speaking to the network, speaking to the internet, also not in JavaScript. Can we think of some other ones? Yeah, Michael.
Fetch.
Well, we're going to learn in a second. I mean, that is, so fetch, people will see, and we're going to use it for sure, is our ability to speak to the internet. So this is our feature ability to speak to the internet. Chris?
Events.
That's, yes, it's very much a sort of interface between these. So let's leave that one out because it's going to allow us to interact between these two worlds. So it's so embedded between the two that I wouldn't want to distinguish JavaScript versus DOM. It acts as an interface between these two. But I guess, yes, technically but it's such an interface between these two. Let's keep that one as, we'll come to it in a bit.
What about IndexedDB?
Yes, absolutely. These ones are just unambiguously IndexedDB. These are unambiguously features. Don't forget the webcam. I believe that's a feature that we can use from the browser. I think have we hit the main ones there?
Is local storage part?
Local storage, excellent. Local storage. Beautiful. Not one of these people is in JavaScript. And we're gonna see, kind of, thank goodness, because all of these things can take a bunch of time, and we're gonna wanna have the ability to do them without doing them in our single-threaded JavaScript and waiting. So, we get, in JavaScript, the ability to speak to any of and use any of these features directly. And that's why it is such a profoundly powerful language. I think Closure is really cool. Higher order functions are nice. Closure is really cool. I think Closure is an amazing built-in feature of JavaScript. But you can see it's still only dealing with one thing. How do we in a sophisticated manner, think about our data and our functionality being together? Because that's all there is. Data and functionality. That's it. JavaScript would be a very unpopular language if that's all it could do. It would be a very basic language if that's all it could do. Instead, it's a profoundly powerful language because we get labels within JavaScript to use any of these features. I call them, which is not a term that's taken off, I call them facade functions because they're a facade. They look like they do JavaScript work. We don't see in them that they're clearly non-JavaScript. They look like they do JavaScript work when they're actually a facade for stuff outside of JavaScript entirely, that we're accessing from within JavaScript. And let's hope, of course, people, and I'm sure JavaScript's done so, that it is chosen names for these outside of JavaScript features that map closely to their underlying feature name. I can only imagine they did. So if we want to access the DOM, we presumably use DOM, right? No, okay. What label do we use, Michael, for the DOM?
Document.
Document. Does that seem helpful? No, never mind. It gets better and better, right? As new features have been released, do we notice that some of these now have the actual official name of the feature? For the console, how do we access the console? Console, that's pretty good. I know we then use the log as one of the methods available within it, but the console is accessed by console. That's pretty fab. How did we used to access the network? Anyone remember the old XHR, right? XML HTTP request. Yeah, XHR. That used to be the label we used for accessing the network. Excellent. What an intuitive name. What do we use now to access the network?
Fetch.
Fetch, exactly. So even more. I mean, look, let's not judge anyone. There it is. Fetch. Beautiful. What about for timers? Hopefully we could say timer. No? What do we use for timers? We already heard it. I think, was it Michael?
Set timeout.
Set timeout, exactly.
Or set interval.
Or set interval. And actually we're going to see today, which is quite cool, we can actually spin up a timer using an abort signal that will allow us to also spin up a timer and potentially maybe limit how long we run what we'll see is a fetch request and maybe abort that based on not getting a result by a certain time, meaning we're going to spin up a timer through a new approach. So probably you can already guess we're going to need to expand our system from JavaScript, and I'm going to add down here from now on our web browser features. And we're going to have a bunch of stuff in JavaScript that does not do really all that much in JavaScript, but instead triggers work outside of JavaScript entirely, and instead triggers work within the web browser. We want to be able to talk to this web browser set of features. So let's just have a little bit of let's remind ourselves. And we have our JavaScript, and it's going to not sit in isolation. It sits within the web browser as a whole, which has a whole bunch of additional features. We saw we have the DOM. We saw we had timers. We saw we had
Storage,
which was the other one. Oh, we had network, access, network, speak to the internet. Speak to the internet, right? That's why our JavaScript's interesting in the browser. And then we get to use these via very, very unrelated labels. Well. Okay, but now we're going to turn on our JavaScript. But our JavaScript engine that we know has, and I'm going to start doing my call stack here. I think it's going to fit. Call stack here. Our JavaScript engine has our three big parts. Has anyone forgotten them yet? No. It's our memory. It's our thread of execution that is single and synchronous. Do stuff one at a time. When people tell you JavaScript's asynchronous, well, I'm pretty sure that main thread is very synchronous, unless something else is going on. And then we have our web browser down here. Everything below here, people, is going to be features of the web browser. We're going to call them APIs. They are features that we can, I stands for interface with, from within JavaScript. So everything underneath here is actually not going to be running in our JavaScript engine. It is not going to be running our JavaScript engine, but we know what we're doing in the first line here. Brady, line 1, what are we declaring? Be as precise as possible. Well, be as fancy technical communication as possible. What are we doing in line 1, Brady?
We're declaring the function print hello.
Excellent. It's spot on. From Brady, there it is, my F that represents the code of that function being saved in JavaScript memory. Now we hit, we're in global. Now we hit our first interesting line of code in here. We are calling what looks to me like a good old regular JavaScript function. One that takes in callback. What function's being inserted over to Chris?
Print hello.
Print hello. There it is. Our whole function definition, our whole code, and our second input to set timeout. And we can go and check this on our, Tenzin, where do we go and check the rules of, say, set timeout?
The documentation.
The documentation, excellent, MDN, wherever. The second input is going to be the number of milliseconds that we want to, not MS, that we want to delay our print hello function before we run it. So we thought, well, presumably that has to happen in JavaScript. Wait 1,000 milliseconds before we then hit our console log me first. And yet we also remembered, maybe we've seen it before, as Matt said, there's no way that we're blocking that single thread. Because of what? Because our set timeouts consequence, people, is set timeouts consequence in JavaScript land, everyone?
No.
Is it in web browser land?
Yes.
Yes. I'm not going to make anyone come up and... Oh, Michael, come on up. Michael, thank you so much. Michael, I need a big old line between where set timeout is being called and where its consequences are going to be. Thank you to the wonderful Michael. There we go.
So it's called
Up here?
in JavaScript, and then it's run in the API.
I need to see a line.
You
All the way down.
want a full line all the way
Yeah.
down? All
Let's give Michael a hand. Excellent, Michael. Thank you, Michael. Yay, well done, Michael. I was going to say we could have done a line down this way, but why take the fastest route? Why not take the literal longest route that we could take? Well done, Michael. An experienced blackboarder there, like a blackboard prankster to make my life. Okay, excellent. So down into web browser APIs we go, where we are going to, well, what did we say set timeout is going to use, Chris, within the web browser?
Timers.
Timer. So our set time out is a label for our timer feature, and I'm going to draw this, people, like this. I'm just going to say we spin up a timer. In fact, yes, our set timeout is going to, in the web browser, I'm going to do this little, I'm sorry, this is not me being in any way partisan to Chrome, but it's the only logo I can draw of a web browser. There's a web browser, others are available, and into the web browser we go where we turn on a timer. What pieces of information would this timer critically need to function? Chris, what information does it need to function?
It needs the callback in the time.
It needs the amount of milliseconds, exactly. So let's set it to 1,000 milliseconds. And it also needs the function to run, let's call it on completion, maybe on completion. You know, when complete, we're going to call our print hello function. And I'm sure you'll have questions about whether that is fully, but we can probably imagine we're not actually fully copying that function in here, as opposed to just referencing back to where it was saved in JavaScript. And, you know what I need to add, people? Forgive me, I need to start tracking our time as we go. So we started this, and I'm going to do green for time passing at 0 milliseconds. Okay, so at 0 milliseconds, let's track. At 0 milliseconds, is our 1,000 millisecond timer, Chris, complete? No, it is absolutely not. It is not complete. And so, what do we do? Well, people, all of our JavaScript work in this line is complete. We ain't sitting on that line any longer. Its only meaningful consequence, technically in JavaScript, it does actually return out some sort of ID that is an ID for the timer. That's not a bad idea. It's to be able to get some information about the timer potentially. But we are, all intents and purposes, finished with this line. So in 1 further millisecond, and in reality it's much faster than that, but just I'm using these ones and zeros as sort of ordinal to say this is the next thing that happens, roughly. The next thing that therefore happens in JavaScript, Chris, is what?
Console.log.
Console log our me first. And there we go. And I'm going to put my console people here, which I know it should be in our web browser, but it's sort of, there you go, but our console there. And into our console at 1 millisecond, what do we get? We get our me first. Our global code is finished running. Maybe our global execution context is popped off and we leave? And we'll see why later, because time is ticking by, and at 1,000 milliseconds, is our timer now going to be complete, Tenzin?
Yes.
Yes, it certainly is. And when it's complete, what is going to be executed, Tenzin?
Print hello.
Print hello. How does a function get executed? What needs to be added to the end of it, Tenzin?
The parent.
Parens. Do we manually put those parens on? I didn't see them anywhere here, right? There's no parens on the end of print hello when it's passed into set timeout. We just passed a reference or a link back to that function definition. When something's going to be executed, Tenzin, where does it need to be added?
To the call
To the call stack. Excellent from Tenzin. Exactly. And so at 1,000 milliseconds, our print hello function is added to our call stack, parens, and there we have much time passed, and 1,000 milliseconds, our print hello function is executed. Everyone together, brand new? Execution context. Into it we go, where we are simply going to console log our hello. And there it is, at 1,000 milliseconds, we have our hello in our console. People, we've added a whole new part and some lovely new colors to our JavaScript and web browser architecture system. We've added our web browser features that can be spun up, can be kicked off, not, by, when I use a word really loudly and it's the wrong word, I do it reverse. It can be spun up by our facade function. It looks just like a JavaScript function, looks like the ones we wrote earlier. But this one ain't doing anything of interest in JavaScript. Instead, as we saw from Michael, it's doing stuff in the web browser, where we span up a timer using the information passed in. You can see why I called it, a facade function, because it looks like it's doing a bunch of JavaScript type stuff. This is a accessor. This is a facade for functionality very much outside of our JavaScript engine. And so we grab our time that's going to spin up a timer for 1,000 milliseconds. We grab the code we want to have run on completion, technically a link back to where it was saved in JavaScript. And then we count the timer up in the background. But in the meantime, in JavaScript, we plow the heck on in our single thread of execution and hit our console log, me first, straight after. And then JavaScript just sits around and goes, well, and we'll see later how it knows. It goes, well, there's stuff tracking on down here, so I ain't going to close up. I'm going to close up shop. I'm going to stay on. And 1,000 milliseconds later, our timer completes in the web browser. And the on completion print hello function says, hey, I'm ready to get back into JavaScript. Run me. And to run me, it gets put on the call stack, at which point we get a new execution context. And at 1,000 milliseconds, we have our console log hello from our print hello function. We're interacting with the world outside of JavaScript now, so we're going to need some rules. So to do so, we're going to walk through this code where we declare our print hello. We're going to have a function that I'm not going to write the body of. And actually, for folk who do go and experiment with this code, it is very, very important that this block for 1 sec is doing something that takes a significant amount of time within our single thread of JavaScript. What could we use? Chris, what could we use to take a significant amount of time within a single thread, maybe block for a second?
A for loop.
A for loop. But by the way, people, that for loop is going to need to be doing a lot of stuff. They're very optimized engines at this point, so your for loop's going to really need to be clever to even take a second. But you can come up with something that could take a second natively. Maybe it's some sort of mathematics you're doing the for loop, something recursive, but it's going to take some, real, computationally taxing stuff at this point to block for a full second. But that's what that function is going to do. So we define those two. We're going to first actual execution run set timeout. And this time we're going to pass in 0 milliseconds. So Tenzin's question might very soon be answered. We're then going to call that block for 1 second within JavaScript land. It's going to block within JavaScript for a full second, and presumably print hello is just going to bounce back onto the call stack as soon as it's ready within that block for 1 sec. That is my no voice, isn't it? All right, good. So let's walk through this code line by line, people, and it should hopefully illuminate that we must have some additional rules or structures to deal with speaking to stuff outside of our very crisp, predictable environment. In fact, we do want to recognize that that's our underlying goal. In programming, even if we have when we're dealing with an outside world, things get unpredictable, right? You make a request to the network, it may take 10 milliseconds, 100 milliseconds, it may never respond, it may respond with some other information. So many different things can go on. That is very, very different to our pure JavaScript, where unless something's broken, it is going to do every single line one after another until it's finished doing those lines. Everything is at least and we do want predictability when we're writing code. So we're going to see that predictability goal is so important that the rules we have for code coming back in and being stuff outside of the browser having an influence back in, stuff outside of JavaScript having an influence back into JavaScript, we're going to need some pretty prescriptive rules. We're going to need something that might even seem a bit overly prescriptive, but at least it means we can always predict ultimately the order of our code execution. But as always, we start off in our JavaScript land, and we have our global memory here, which is going to be drawn with a straight line for once. There we go. But now, and we have our call stack. Here it is, which is going to keep track of what JavaScript code we're running. Then we're going to have our thread of execution. But now, people, what, Chris, do I add that I didn't have before? What's my new part of my code below and outside of JavaScript land going to be called? The web browser features, or we tend to call them the web browser APIs because we access them, we interface with them from within JavaScript. The I stands for interface. Okay, good. So into our code we go. And the first thing we're going to declare, Joe, you're up. Give me my first two function declarations here.
We're going to define a function called print hello.
Yep.
And then we are going to define a function definition for a function called block for 1 sec.
Block for 1 sec, which we are not going to write out the body of that code. So to be really clear, people, we're going to need to actually add some code there if we were running this directly, but we don't need to fit it on the screen here. But it would be doing something like a loop. Next, we hit our facade function call, or if we want to be correct and fancy about it, we hit our call to a web browser API or web browser feature, this one being via set timeout, therefore this one being what, Joe?
Timer.
The timer. And we're going to pass to it what, Joe?
2 arguments. The first, the function definition print hello.
Beautiful, the function definition, right. Are we calling print hello at this moment?
No.
We are
parens.
100% not, exactly. We're just passing the definition and
The second, the value of 0.
yes, which represents, because we know this from looking at set
0
timeout docs.
milliseconds.
Yeah, sorry, I talked over you. Say that again, sorry, Joe. Yeah, 0 milliseconds. Joe said 0 milliseconds, exactly. Set timeout. Michael, does it have consequences in JavaScript that we're interested in? No, where does it have consequences?
In the browser API.
In the browser. And so I'm going to do my little Chrome logo, forgive me for that. No favoritism here. And turn on a timer down here in the web browser with the all-important information being, also by the way, did we notice how nice and straight Michael's line was and how nicely drawn the arrowhead was? Yeah, I know. What a way to show up my... It is perhaps misguided for someone who has, at best, flawed handwriting, at worst, terrible handwriting, to be so committed to a blackboard. Never mind. So our 0 milliseconds gets thrown into our background work in the web browser where we're doing, where we turn on our timer and set it to 0 milliseconds. We know that when we're finished, we can say, and let's just say on completion, but when we're finished, we are going to want to run what function, Joe?
Sorry. Block for 1 sec.
What, when we're finished running our timer?
Right, on the timer for
What's the function we passed into the timer?
print hello.
Print hello, perfect. Excellent, there it is, the print hello function definition. What did I forget? Time is passing in this world now. So at 0 milliseconds, we have, well, here's the question. Almost a trick question. Tenzin, at 0 milliseconds, is our 0 millisecond timer complete?
Not yet.
To be fair, I've noticed every time I ask this, people think no. But at 0 milliseconds, is a 0 millisecond timer complete?
I guess so.
Yeah, I guess so. Exactly. It's complete. It is absolutely complete. So presumably, our print hello function gets thrown right back onto our call stack. It's ready to go. It's ready to run. And yet, it certainly does not. Let's just make sure we have our console in here as well. It certainly does not. What the heck is happening? Our print hello function is ready to run. It should be added straight back on the call stack, right? It's a 0 millisecond timer. It's complete. Exactly as Tenzin said, it is complete. in the background. Okay, I'm not going to be around the bush because why would I? It turns out, people, we have another feature that we need for this interaction between an outside world and the JavaScript engine that sits as an interface between the two. It is going to be something called the callback or task queue. And it is into there that our print hello function goes at 0 milliseconds. At 0 milliseconds, even though it was immediately set up to run after 0 milliseconds, it cannot come back on the call stack. We'll see why in a moment. Instead, it's going to be added here. Print hello. It's going to go and sit and wait in this queue. Sit and wait in this queue for, well, we'll see what in a moment. And we, though, for now, plow straight on, and at 1 millisecond, and we're sort of just being ordinal here. We're just talking about the order of 0 first, 1's after, not per se actually a millisecond later. It would be much less than that. We're going to hit the call to what function, Chris?
Block for 1 second.
Block for 1 sec. And we're going to execute it. And we're going to add it to the call stack. Block for 1 sec. And we're going to create everyone together a brand new execution context. Into it, our thread goes. Maybe I should do the thread in green. No, we'll do the thread in, because that's time, isn't it? We'll do the thread in white, because it's a JavaScript thread. And into it we go, where we are going to run for 1,000 milliseconds some sort of for loop. We don't know what it's going to do, but it's doing it very much in JavaScript via, which means it can't be a very long task, because JavaScript literally doesn't let us do any very long tasks directly in JavaScript. It has to be lots of tiny tasks, meaning like a for loop. So like doing lots and lots of things very, very many times. That's what we're doing inside of here, maybe some sort of loop. And I guess at any moment in that, our print hello is going, excuse me, you're doing a for, can I come back on? Do we think that our print hello is allowed back on the call stack during that block for 1 sec function call? Absolutely not. After 1,000 milliseconds, we are now back out into global at 1,001 milliseconds. And so we are going to pop block for 1 second off the call stack. Off it comes, off it pops, and we're back into global. Now, presumably, print hello is allowed back on the call stack. What do people think? No. No, exactly. Instead of 1,001 milliseconds, what, Chris, is going to be executed?
Console.log.
Console log me first. And there at 1,001 milliseconds, we get the me first in our console. And now finally, at 1,002 milliseconds, what finally will be added back to our call stack? Tenzin, what do you think?
It's the print hello.
It's the print hello. It gets dequeued and gets added to our call stack. Brand new execution context for it. There it is. Call it. And what does it do at 1,002 milliseconds? Whew, this is when I start to get tired from running around the board and changing my... it console logs hello. Oh my goodness. We have perhaps the strictest rule. What do we think our rule is? Yeah, Joe.
Callback queue doesn't run until the end of the global queue is finished.
Until all of our global, not just until stuff on the call stack is finished executing, definitely that, but until all of our global code is finished running. And I'll be honest, when I first did this, I almost couldn't believe, you could have a million console logs and still everything would be left until after. But it comes back to this fundamental idea that we want predictability. And if predictability is all global code must be done before we ever run anything out of the callback queue, at least that means we can be confident that all global code will be run and at no point might something jump back in. It is a strict rule, but it is a fundamental rule. Let's introduce one final piece of this puzzle, which is JavaScript's tool for doing that checking. How does it know that the call stack is empty? How does it know that global's finished running all of its code? How does it know that there's stuff waiting in the queue? It has a key feature that sits between our queue and our call stack and is checking before every single bit of code is run, checking on repeat. It's looping, checking all the time. Is our call stack empty? Have we finished running all global code? Is there something in our callback queue? Is our call stack empty? Have we finished running all global code? Is there something in our callback queue? It's looping over that every single time and saying, is there some new information? Is there something that happened? Can anyone guess what Matt.
Micro test.
We're going to see that one very soon. Chris, can you guess?
The event loop.
The event loop. Do not fear, Matt. We're going to see the microtask queue in a moment. It is where shall I put it? Let's put it on there we go. It is the event loop. And its job is pure and simply to check on repeat, to check, is my call stack clear of any code, any function's execution context on it? Has it finished running all global code? Does my callback queue have something in it? Here, is my call stack empty? Sorry, callback queue, you just got to sit there waiting. All the way through, is my call stack empty? No, it's got block for 1 sec on it. Hit the end of block for 1 sec. Does my event loop go, hooray, callback queue, you're good to go? Nope. Instead, it says, shoot, there's still a bunch more global code to run at console log. Or a bunch more, one more function. If there are a million, there's still a bunch more global code to run. Is my call stack empty? At the end of my, when I finally finish running my console log me first, now my call stack is finally empty. My callback queue has my print hello function that's been there waiting since the very, very start because it immediately finished and was immediately queued up, ready to go. I'm ready to go. But it couldn't enter until the event loop saw that the call stack was empty, all global code had finished running, and finally it will grab our print hello and shoot, I should have dequeued it. It will remove it from the queue and add it to our call stack. We are now able to hit our callback queue, add it to our call stack, and execute our code. Here we go, people. So let's do thumbs in a second on the expansion of our core JavaScript model. From having our synchronous code execution running through the code line by line, our synchronous execution with the memory and the call stack, to having a whole new package of tools available to us, our web browser features, or in Node, our Node background features. And our ability to trigger them from within JavaScript with functions that look a lot like JavaScript. In fact, I call them facade functions for that reason, because they even get called with parens in the same way. You pass stuff into them, no problem. We find out about them on MDN. We need to, because the names on MDN, the names of the features are often different to the labels within JavaScript. And if that work's happening in the background, we do need some rules and structures for how to get that work back, get the outcome of that work, back into JavaScript, because we must have predictability within JavaScript. What do we have? When the background work is done, any associated function that we want to have run back in JavaScript, that's triggering JavaScript code. That's triggering JavaScript's single thread of execution. We better have a place to queue that work up so it don't just land in any moment. As we heard from Chris, as we heard from Joe, we heard from Tenzin, wait, can it just come back on any time? And as we heard from Tenzin, what if it finished immediately? Surely we get to run it right there and then. Instead, it goes and sits in the callback queue until the event loop that is doing every single tick of our code running, every single task we do on the within this environment, it is checking, should I run anything out of the callback queue? Not until. 2 strict rules. My call stack is fully empty and all my global code has finished running. At which point I can grab my print hello function and put it into the call stack. The event loop is checking just our call stack. we might see there might be some, just our callback queue, we might see that there are some other. And if you want to go and watch the node hard parts, well, I don't want to give it away. So I hope there's only one queue. That's all I'm going to say. I can only imagine. It would be very bizarre if in Node there were up to 4 or 5 different. Okay, all right. You imagine having to blackboard through Node hard parts? Imagine. I can only imagine there must be one queue. Why would you need more? One thing to share here, I didn't really stress enough, forgive me, is that these callback functions, we saw like before, a function is passed to our set timeout, and it is now we don't mind this name. Now it is called back in to JavaScript land. This feels a lot more like a reasonable meaning of the word callback. But we use it as we saw yesterday in higher order functions as well. But this approach was the standard approach for interacting with the outside world of JavaScript, outside world of the web browser from within JavaScript. This was a standard approach until ES6. In ES5 and before, and set timeout still works this way, how do we do it? We pass in a function, our facade function set up work in the background, and more or less did nothing of interest in JavaScript. Now that can be a problem because what if it's a bit odd that you could have tons of background work going on and within JavaScript no serious way of tracking the work you're doing. That feels, not ideal. So problems. And another problem, our response data. So a lot of these background tasks go off. In this case, we didn't really have any data to retrieve, but a lot of these background tasks go off and get data from a network. The only place that data is going to be available in is the function that runs on completion. That's where it's going to populate, but we'll see that later. That was a bit of a problem. It meant that within this style, we had a problem where when the print hello function ran, for example, if that instead had been off to get a network piece of data from TikTok, we'd come back with that data, it would only be available inside that associated function. That's also by design. Where else is it going to go? But that could be a problem. We'll see a solution in a moment. They call that callback hell. Maybe this is a slightly strange mental model. The idea of, they call it passing control, right? Like you're passing a function into another function only for it to run actually much later. It certainly looks confusing that print hello timeout 0 looks like it's going to call print hello right there and then, but because it's being passed out into the browser and being brought back in later and only executed when the event loop sees the call stack is clear and global code is finished running, because of that, it ain't the most intuitive approach, most intuitive design. Now, what I would pitch for you is it's super explicit once you understand how it works under the hood. One queue, background work, all of these facade functions set up background work. When they complete in the background, then they get passed to the queue, when the queue, where they sit until all global code is finished running. We have complete confidence in order of execution. If not the exact timing, I can't tell you when work off to the network would complete, but I can tell you it will only ever run in JavaScript once all my regular code has finished running. But in ES6 and beyond, we got introduced a new approach, that of promises. These are what I call two-pronged facade functions. They have consequences both within the web browser, because they're heading off to do some stuff outside of JavaScript, but they initiate some background web browser work. That means like setting up a timer, speaking to the network, but they also return a placeholder in JavaScript, an object, a special type of object known as a promise, immediately that allows us to, A, know that we've set up some background work and keep track of the fact that we've done that within JavaScript. That's quite nice. And B, is going to open up ways of interacting with the data that does get retrieved, potentially from the background work from, let's say, TikTok server, open up ways that we can interact with that look on the page much more readable. I would argue they actually obscure even more what's really going on, because under the hood, it's going to all be just the same as this, well, with some key new cues, but nevertheless, this has become the standard approach, and it replaced what we used to use for accessing the network known as XHR with our new promise approach, which is achieved through the built-in two-pronged facade function known as what? We don't use XHR anymore for accessing the network. Chris, we use what?
Fetch.
We use fetch. Exactly. So here we go. ES6 onwards promises. We are now going to introduce the 5 letters, F-E-T-C-H, fetch, that I think do the most stuff of any 5 letters in JavaScript. They are going to kick off background work, speaking to the internet, speaking to TikTok. They're at the same time going to have an effect directly in JavaScript. You can see that because when I call fetch, my two-pronged facade function, not only am I going to be setting up some work in the background, but I'm also going to be assigning its immediate return, not the data, but its immediate return, because the data work is going to the TikTok data is going to be all off down here in the web browser. But I'm immediately going to assign to future data a special object. This is its other prong. I call them two-pronged. One prong goes off to the web browser and does stuff. The other prong goes and returns an immediate object into future data. And that object is going to act as a placeholder for the data from speaking to TikTok. And when it returns, hopefully we can use that data in some sort of way. But in practice, people, this is still a language of JavaScript which is synchronous here. Background work comes back in asynchronously out of order. So under the hood, even though this looks, I mean, you look at this, you might be like, wait, when future data comes back, we're going to display it. Are we doing it right there? Even though this code looks more linear and intuitive, under the hood, we're going to have very, very similar pattern to what we've just seen. Okay, so we are going to use our new tool that came available to us in ES6, promises, that allow us to speak to the web browser, in this case to use it, well, we're going to use promises to use the network feature with the built-in label available to us, fetch. And this one is going to presumably work pretty similar. Set up background work, in this case, speak to the internet to get our latest videos. So we're going to hit that URL, but via our web browser features. And when we're done, we're going to want to use those URLs, the return data, the retrieved data from TikTok's headquarters, presumably, hopefully, a nice list of videos, depending on how our API at TikTok is designed, a nice list of videos. We're then going to want to display those videos. But what the heck is going on to make this possible? Well, it's all going to depend on these new two-pronged facade functions known as promises. So here we go. Let me draw in my web browser down here. Let me make sure I get about the right amount of space. I think this is probably about right. Draw in my web browser. Everything below this line, oh dear. Everything below this line is web browser stuff. Okay. Everything below this line is web browser, APIs or features. I here just means interface, things we can interface within the web browser. We have, as always, our global execution context with our memory. There we go. We'll have our console here. There it is. And we're going to have our JavaScript engine kick off here. Let's make sure our pen is working. And we'll have our call stack. Oh, dear. Oh, no. Our call stack. There we go. Beautiful. Our call stack right here, which as soon as we kick off our code, we're going to have our global execution context kick off. And so here we go into JavaScript, single thread of execution, and at, well, we're not going to hit 0 milliseconds yet. Let's first declare a function. Ryan, what function do I declare in my first line?
Display passing an argument of data.
Yes, but we're not going to pass it in yet, are we? We're just going to save the whole thing here and jump down to left-hand side of our next line in our thread of execution. What is it going to... I'm not going to make you do the right-hand side yet, Ryan. Left-hand side, what are we declaring?
declaring future data
Future
constant.
data. Okay, raise your hand if you say data. And raise your hand if you say data. Is that not that's not a thing in America? Okay.
Some people say data.
Data. Okay. Great. Good conversation, everybody. That was amazing. All right. So future data. Now, at this point, as always, what's future data's value, Tenzin? What's the value of future data at this point?
I think it's just a call to fetch.
Oh, do we ever store calls to stuff?
Oh, it's undefined.
Right, uninitialized, but yes, exactly. We don't yet know what to store. Nice work, Tenzin. Exactly. We do not know yet what to store because we don't yet have a result of calling the right-hand side. Now, if that right-hand side is actually going to be inside of the call to fetch, speaking from JavaScript off to the internet to TikTok, it could take a day, and it would block the further running of our code. So I bet you that fetch on the right-hand side must be triggering some background work in the web browser, but it's also clearly going to return something into JavaScript. It's going to be one of these two-pronged, but for now it is uninitialized. But let's hit this really, really significant line. Future data is going to be the return value of calling these five most powerful letters in JavaScript, fetch, to which we're passing. I'm just going to shorten it a bit. TikTok.com/will. Okay. All right. Here we go. Can I get this right? We do know that we're speaking off to the internet. Chris, what feature of the web browser are we going to use when we run fetch? Network. So immediately we head and turn on our network request. Network just meaning to speak to the internet. Our network request feature. Here it is, network. Okay, we need some info for that. We need the URL or domain, and we need the path, the string at the end that tells us which bit of TikTok's server or computer we're going to want to access. So we pass in our domain. Oh, you can see I used to write something here many, many times that was not TikTok, but was instead Twitter. That's been an adjustment. TikTok.com, and then our path will. We can actually send and post. The term post means send to TikTok some data, maybe a comment, maybe a new video description, maybe a new video. That would be a post. We can set that up within Fetch by passing in a second input that contains information about what we're going to want to send to the internet, because we have different ways of speaking to our TikTok server, our TikTok computer out there on the internet. Fetch defaults to a particular way when we want to get data, known as get. But we could set that instead to, I want to send some information to TikTok that they can add maybe to my account. That would be our post request. Strange to post, but it's a request to say, hey, can I do this? Can I have this interaction? This is going to be get by default. That's all included in this fetch call immediately. Okay. That, I probably suppose you can say here right now, that is going to immediately say head off to TikTok's HQ. I can't really see what else. Head off to TikTok's HQ. I'm going to sort of draw it like this as something between a building and a server. Send a message to TikTok in the format of the HTTP, P stands for protocol, but the HTTP protocol. Send an HTTP message off to TikTok and say, excuse me, we want to get some information from TikTok of maybe what, the latest video links. It was easy when it was tweets. The latest video links from Will's account. Go off and do it. We did all of this at our 0 milliseconds. All of this at our 0 milliseconds. Okay, that is our network piece done, is it? At 0 milliseconds, we've headed off to TikTok, all from this one line, and none of it in JavaScript. I want to make sure I hit everything. There's so much bloody stuff it does. Is it complete at this point, do we think? Michael, do we think that we've got our data back after 0 milliseconds? Physics won't allow it. We need some time. So at 0 milliseconds, I'm going to have a little sort of subtitle here. Complete. At 0 milliseconds, no. On completion, I'm going to hopefully get some data back. Some data retrieved from TikTok, my list of video URLs, my list of video links that I'm going to want to somehow use in JavaScript and maybe display. For now, probably in our console, but eventually we'd do it on our user interface with the help of the DOM. How the heck are we going to get them back in? Well, it turns out this is a two-pronged facade function, whereas our set timeout had one prong. I mean, technically, you could get something back in JavaScript, but it wasn't that interesting. This is a two-pronged one that allows us to also within JavaScript immediately return into our future data label a brand new, well, it's been around for 10 years now, but a brand new versus the old-fashioned way object, oh no, a brand new object, people, called a promise object. And this object is going to act as a placeholder for the data that we get back from this background work, and we'll see soon a place in which we can store what code we want to then run on that data. A promise object that's going to have two properties on it. One is going to be result. Now we're going to see these are both hidden properties, but this result property is going to eventually have back from our background work, well, we'll see. Let's just put this object here into our future data label with our result. And for now, that is undefined. We have nothing stored in it. Yeah, Chris?
This is something that the fetch API creates, right?
All being done by these 5 letters. The F does the... No. The E does this... Okay. Isn't that wild? All being done by 5 letters? Okay, so... And the really powerful thing about this as well is that these 2 prongs have an intimate bond between them. Where when the network response comes back, speaking to TikTok, where when it gets back with its video links, where will the data, what do we want to have happen on completion? Well, Chris, what do you think we'd like to have, perhaps, we got our data back, where would we like that perhaps to show up back in JavaScript on completion?
In the future data.
On which property?
Result.
On result, exactly. That's where we'd like it to come back. We would like for future data dot result. Now, technically, this is a hidden property, so it's actually in our square bracket, square bracket, square bracket. But back on result, we hope we're going to get our data from speaking to TikTok. All of this, people, I think I've hit it all. Was set up by these 5 letters. And this isn't even like going under the hood in a sense of like, oh, how intellectually curious, so much as you can probably, hopefully see this stuff's all pretty crucial. You've got your work being done in the web browser to speak to the internet. That's pretty crucial. You've got your object being created in JavaScript that's going to have an intimate bond to that background work such that on completion, hopefully it's going to be updated with that value. That's 5 letters. Okay, well, I didn't want to get that data back from TikTok for no reason. I wanted to get it back so I could doom scroll videos. I wanted to get it back so I could feel a sense of ennui. Okay. So I need to run some code, on that data that comes back. How the heck do I set a function up, some code to run, code has to be wrapped in a function up, that is going to, on this result property being filled in with my data that I get back from TikTok, some sort of function running. Well, it turns out I get on my object, this promise object, that's just special JavaScript object, a promise object, I get on it another property. And that one is called, I'm just going to say, well, no, I'm going to call it its full thing for now. Fulfill reactions, and it, people, is an array, an empty array, we'll just call it fulfill, an empty array, people, into which I can add functions that I want to have run when my data comes back. And that I know that result value will be passed into those functions as the input. Okay, that would be pretty powerful. That would allow me to, when I get my data back, to also run some code on that data. So sorry, all of this is still within those 5 letters. How can I add, do we think? What method, is available on my future data object that allows me to push, well, perhaps what I could do, could I do this? Maybe I could do future data. What method do I have available to me to get stuff into arrays? Ryan, what method is available to get stuff into arrays in general? Push, exactly. Future data dot fulfill reactions dot push, and I could pass in then, let's say, my display function. Because unfortunately, my fulfill reactions property is a hidden one, I can't just access it directly. But don't panic, can anybody spot, well, everyone together, hopefully, what method do I get available to me on my future data promise object that I've called future data that I can use to push a function into that fulfill reactions array? What method do I get available to me, everyone together?
Then.
Then, exactly, then. There it is. That's going to allow me to actually get access to this hidden array and add stuff into it, which is exactly what I'm going to do in my next line. Future data, use the built-in available, and we'll see, later today, how we have this function then, which isn't directly on future data. How do we have access to it? Some of you might already know, but we'll see that in the prototype chain to come, and pass in the display function directly, and that is going to push the display function into this, there we go, into this fulfill array. Oh my goodness. What a setup. What a flippin' setup. That was all with just our fetch built-in 2-pronged facade function. It set up work in the background. It created in JavaScript an object for tracking that background work. That object allowed us to also add a function that when that background work completes and gets some sort of URL TikTok thing back, that we'll be able to, when we fill in that result property, that it will also trigger automatically some code to run on that data. But for now, people, we plow straight on. And we hit at 1 millisecond. What? Joe, what do we hit at 1 millisecond?
Console log.
Console log. Good old.
The string me first.
Me first. And in it goes me first. Okay, at 1 millisecond. Yay! Yeah, go ahead, Chris.
Since that interfaces to web browser, that one doesn't go on a work queue?
Ah, Great question from Chris that was definitely not teed up earlier. Great question from Chris. Chris said, hold on, console is also a web browser feature. We don't have it listed here now, but we did. That's also a web browser feature. So why is that one not setting up in the background? Well, it is, but then not going into the queue, the work involved with it. We don't want to have all of our background API features put work in a queue. In some cases, we want to be able to do that work immediately. Particularly when it comes to dev tool work, we want to be able to see the state, the live data application at that moment. So our console log is one of our web browser features that actually runs directly where it is called. It doesn't actually, it sets up work in the background to speak to the console, but it does so without any work, and of course there isn't a function here delayed, but it doesn't delay the displaying of that text until our global code is finished running and all our execution context is finished running, because I want to see the state of my application live at that moment. While we were chatting there, our request at TikTok was received and back came at, let's say, about, I don't know, 270 milliseconds is what I often say. Let's say it's 270 milliseconds. Back came a response. Now, in practice, this response will have come back as an HTTP formatted message, and we would then want to do a little bit of processing on it. In fact, the browser will do a bunch of processing on it, but because we're interested here primarily in what we do with that response, while at 0 milliseconds our work was not complete, at 270 milliseconds our work is now complete. Now, we would have got back, and we would be able to work with a JSON object with a bunch of information on it. We're going to keep it simple, and we just got back our, I mean, now I don't even know, because I always used to do tweets, but now it's video URLs. I'm afraid we're still going to have got back just a nice friendly response from TikTok, a video with the name of, it's just, what's a good video name of? No, I don't know.
Cat meows.
Cat meows. Yes.
Learn JavaScript in 5 minutes.
That's very long. Let's have, I think, cute cat. Here we go, cute cat. Cute cat. Came back. Yay. I don't know. I don't even like cats. Let's have cute dog. I like cute dogs. All right, cute puppy. Puppies. There we go. Oh, that's almost more lame. I used to just do hi, but let's do cute. Brady's not approving of the cute puppy. All right, we're going to have puppy has adorable trip. No. Okay.
It's the censorship that bothers us.
Cute. What about censorship? Okay, all right. Cute puppy. There we go. Our cute puppy video came back, and where is that going to go? Where is that string going to go? Well, it's going to go straight into, on completion, our result property on future data. At 270 milliseconds, we get our cute puppy, there it is, on our object. And at that moment, what happens? Well, we have a function ready to execute. And so at roughly 270 milliseconds, we are going to add our display function to the call stack, pass in, note how JavaScript is adding our parens for us, but it's also going to automatically insert the data into that function. In the input goes of cute puppy, the string, and our display function is going to execute with cute puppy as its input. And we're going to create together a brand new
Execution context.
execution context. Beautiful. Into it we go. And in our local memory, we are going to have, we know how our fetch works, that the associated promised object that gets returned out of it, to which we can add a function, that function will receive automatically the data we got back. Knowing that, we made sure the function that we're going to have automatically run has a little placeholder for that. What's the placeholder known as, everyone together? A parameter. Well done. Exactly, a parameter. And our parameter's name was what? Ryan?
Data.
And we are therefore going to know that this is going to automatically pass in JavaScript. Sorry, it's going to automatically pass in the argument cute puppy. And so when we then console log data, we are console logging cute puppy. And so at 270 milliseconds, what, Joe, will we see in our console?
Cute puppy.
Cute puppy. And we know that's the video for us. Oh my goodness. Oh my goodness. I mean, I do like the colors. Oh my goodness. Thumbs in a second on what we have done here. We now have a new way of setting up background work in the web browser that not only sets up the background work, but also in the foreground creates an object that acts as a placeholder for the data when it returns is retrieved from speaking to TikTok and is automatically filled in with that data at the moment of completion of that background work. Okay, great, but what can we do with it? Don't panic. We also got the ability through then to add a function to the list of functions that would automatically be triggered to run at that moment of the value property, the result property being filled in with cute puppy, our retrieved data, which was automatically run. How do we run? Well, we add to the call stack. Straight there? Well, we'll see. We add to the call stack and add parens to it. We didn't have to do that. JavaScript did it. And we didn't have to insert the data. Automatically, it was done for us by JavaScript. Brand new execution context. We made sure we had a placeholder ready, our data parameter, and it got filled in with that cute puppy string, the data we got back from TikTok, and was, I should have done my cute puppy in purple. So cute puppy, there it is. Cute puppy is our data that came back. Cute puppy, cute puppy, cute puppy. There we go, cute puppy. And there it was, our cute puppy was filled in here. That was the update on completion. Go back into JavaScript, find the future data object, set the result value to the string of data that we got back, automatically trigger the display function that we added to future data's objects list of functions to run on completion through the then method, and then that function was automatically run with that input data. People, let's have thumbs. You lost me. I do not like speaking to the outside world. I'm clear. I have clarifications. I'm seeing a lot of thumbs up. Tenzin's got a clarification. Joe has one. Joe, give us a clarification.
So yesterday every time we were talking about what we were writing to memory, we were really looking at it within the scope of the execution context within which that memory was being used. Yes. We had our local memory, we had our global scope memory. Now, in this example, future data is being established within the global scope of memory, and yet the web browser also seems to have access to it outside of relying on the callback queue tacking it on at the very end, because we're updating the result of future data on completion, not programmatically within global, but simultaneously from the web browser. So I guess I'm just a little bit curious about when we declare future data and we invoke fetch, the return value of fetch, is there something about that object that sets the scope as wider than the global context?
Sets the access to, it is this object we have in our web browser API, because this fetch two-pronged facade function got us both the JavaScript object and our network work in the background. These two are intimately connected. And I will say, I'm going to do the implementation. In terms of exactly how it gets that reference back, all that we need to know is that on completion, because this promise object was produced by the same fetch call, in fact, it has two consequences as the network request. This network request maintains a reference to, a link back to this saved object. And that allows it to then update that property. Now, how is that possible in the broader sense? because JavaScript is running within this larger system known as the web browser, and this interfacing between the two of them is, and that is a, quote, implementation detail, that is the reality of running a runtime within the browser as a whole. You're able to, from the browser APIs, make references back to positions in JavaScript memory. And that's exactly what the browser is doing here. That allows it to, when it completes the work, go and update the JavaScript object. It is absolutely not getting a copy of this object in the browser, only a reference to that position in JavaScript memory. One sec, Chris, we'll do Tenzin first.
Oh yeah, I just have a hypothetical scenario. Let's say you have two separate calls to two different URLs. The data from those two URLs to interact with each other. How would you do that so that you don't kind of, in an asynchronous way?
Yeah, absolutely. We're going to see that on the very next slide because, flippin' heck, if you hadn't spotted yet, the similarity to our old callback style, where the data is only available within our function that we know is going to be triggered to run when our data is retrieved from the background, that hasn't really changed. We still ultimately only get access to this data within this display function. Because technically, even though, and I'll adjust this in a second, but even though our cute puppy string is added to a regular JavaScript object in our synchronous environment, we can't actually use that data until, well, actually, in reality, that cute puppy value is not added and not displayed until, well, something's going to have happened in global. We're going to have to finish doing some synchronous stuff in global. So we'll come back to it in a second, Tenzin, because it's going to be showing up in a moment. Chris, do you want to?
Similarly, the example shows those objects being created in a global context, but you can do this in a temporary execution context as well. And those objects have a life outside because something else creates them, right?
Why do they persist? Well, so if we define this in a local context, why would they persist? Well, we saw yesterday the heap, meaning any object that is defined is technically stored as a reference to its underlying position. Therefore, even if we lose the name of it in JavaScript, the object is still going to remain in that heap of objects as long as the web browser references it. And that comes back to Joe's point that actually references to stuff in JavaScript made not even from within JavaScript, but by the web browser, persist the existence of, for example, the promise object, even if it were actually defined inside a function call that upon exiting, you're like, well, wait, do I still get access to it? Well, I don't need it in JavaScript because the only thing that can actually use it is going to be the function that was assigned to it, and that's only triggered by the web browser. So the web browser is the thing that persists the reference to the data. Great questions. Does that also start to help, Joe, with yours? Yeah, great framing. So let's see what it says. Our ES6 solution and onwards is promises. Special objects built into JavaScript that get returned. I mean, you can also see this was a very cool. JavaScript the hard parts I first gave before ES6, actually. When it came along, my goodness, my async hard parts had to add, a whole piece. You'll see in OOP, we had to add the whole class syntactic sugar, we'll see, and now even more features. But a lot of change in that period has become very established. These are really great additions that are now pretty standard, but we haven't had the same number of new additions in the last few years. A lot of the stuff has remained the same. ES6 solutions, I sort of see, funny to say ES6 when it's now 10 years old, but it has become the standard. And that is promises. Special objects built into JavaScript that get returned immediately when we make a call, when we run a web browser feature using something like fetch, that's set up to return a promise. Some of these web browser features are not set up to return a promise, like our set timeout does not. Promises act as a placeholder for that data that we expect to get back from the background web browser features work, stored in that hidden property result. Hopefully it's going to say, and our then method is going to enable us to attach functionality code that's going to run on the completion of the background work and the filling in of that result property. Any code function you want to run or retrieval from internet data must be also saved on the promise object using the then method that stores them on this fulfill reactions, sorry. What did I write results there? Yeah, fulfill reactions that we can, and this is a hidden property defined by the spec, meaning I used to refer to it as the onFulfilled list of arrays. You can really call it, technically it's not explicitly available to us, so we could just call it, I don't know, functions that will run. The spec technically calls it fulfill reaction. Actually, it technically calls it promise fulfill reactions, but we know it's the list of functions that will run. Promise objects automatically trigger the attached function to run with its input being the retrieved result data. Okay. Nobody raised, by the way, which I know you're all wondering, because I know you're all curious about this. Well, we just added display back onto our call stack. What happened to our queues? Well, it turns out that there might be a little bit more to the queuing mechanism than we revealed so far. We saw one queue, our task queue, our callback queue, but what if there were, well, we'll see. We're going to need to see my most complex code today. We have 3 function definitions: display, print hello, and a block for 300 milliseconds. We're then going to call set timeout. We're going to call our 2-pronged fetch. We're going to call our block for 300 milliseconds, and we're going to see how this code executes. Once we've done this, we are done with our async. Well, no, we're going to add how to abort a promise, I think we'll have time. And then we are on to OOP. Well, we have just seen the remarkable fetch 5 letters that changed the world of JavaScript. 2 prongs, one was hitting our web browser features and the other was hitting our JavaScript with a placeholder object into which the background work would eventually load its data. And we then attached to it a function that would then run automatically when that data was retrieved, in this case from TikTok. So now, let's see, when that work is complete, what the heck are the rules for that data getting back into JavaScript? We just said, when the background work completed, let's have our display function from the promise object added to the call stack. But we know it can't just go on the call stack. We know that we have to have some sort of queue or rule for getting that data, getting that function back on the call stack. So let's see it all in full here in what is going to be a wild ride of diagramming. As we've added 3 functions here, we're going to have both the old school style set timeout with the callback, no 2 prongs there, and the new school with the fetch, 2-pronged consequences, both promise and web browser work. So, you have to tee yourself up for something. Here we go. We have our JavaScript. We have our memory in our global execution context in our JavaScript engine. We have our web browser features. Is this enough room? Maybe that's enough room. We have our web browser oh dear. Okay, we have our, maybe I'll just do it without we have our web browser features. Yay. Web browser features or APIs. Beautiful. And we have our call stack that keeps track of what code is running and where are we at in our thread of execution in JavaScript. So let's get into, we have all our system here, right? Thread of execution, memory, call stack, that's JavaScript land. Maybe even draw a little box around it, that's JavaScript land. We have our web browser land below. You know what? Let's put our callback queue in now. We know that's definitely part of our system. Callback queue is now a part of our system. Let's put in our event loop, because we know that is also now part of our system. We'll do our little thing. It's checking anything in the callback queue. Is the call stack empty? Is global code all running? We can move stuff from the callback queue to execute it on the call stack. That's not a bad baseline system to be working with. And then I guess we could say we have over here, off at TikTok's headquarters, we have our server, computer connected to the internet, ready to receive requests from our computer system, our computer, our web browser. Okay, everyone happy? Oh, we have our console. There's a lot of stuff that computers do. Very powerful. Okay, I think we now have a full template. You could even copy this out on your notepad and see how the system runs for any situation. I could even release a series of notepads that you could buy with pre-drawn. That would be fun. What a fun gift that would be for all your friends, neighbors, and loved ones. And your worst enemies. Okay, here we go. Let's go. We've got 3 functions to declare. Let's start with Michael. Declare me my 3 functions here.
Okay, we first declare a function called display.
Yep.
Do you want me to say the...
No, because in the end, we just grab all of its code, stick it in memory. I don't even like to talk about the body of the function until we call it, because it gives the impression we're, evaluating it in some way. We don't touch it until we call it. So then we say, what function next?
All right, so we declare a function called print hello.
Beautiful.
And then we declare a function called block for 300 milliseconds.
Right, and we're not going to see how that one works because it would take too much space, but we know it's going to do some sort of long loop, lots of different small steps that will take 300 milliseconds and block the single thread of JavaScript directly, not set up some background work, but do it directly in JavaScript when we called it. Okay, now we go straight into some actual code execution. What's our first? Talk me through that next line, Michael.
All right, so we call set timeout with our function print hello pass and a value of 0 for the time.
Perfect. So are we doing anything of interest with this function here in JavaScript, Michael?
No, we don't. We can't see the execution of it, so we don't go into...
No, that's right, exactly. We are heading off with this function off to our web browser, where we are going to set up what background feature, Michael? What does set timeout trigger in the web browser? The creation of a what?
A timer.
A timer! Excellent, Michael. Absolutely. Do not fear, Michael. Believe me, that is a experience as old as time. And what does a timer need to know here? What information does it need to have, Michael?
The function is going to call at the end.
Yes, nice.
And then the time it's going to wait.
Yes, in milliseconds, exactly. So 0 means it's going to wait 0 milliseconds. And when it is complete, on completion, it is going to call what function again, Michael?
Print hello.
Print hello, spot on. Print hello is going to be called back in JavaScript. So actually it just passes a link back to the print hello function, a reference back to the JavaScript print hello function in memory. Almost there. So then, is it complete? That's my question. Is it complete? And the answer is at 0 milliseconds. Is a 0 millisecond timer complete? Sounds like a trick question, but it isn't. Is it complete, Michael?
Yes.
It is. Spot on. So our print hello function is going to be out of the call stack?
No.
No, where's it going to go?
Going to the callback.
Callback queue. In it goes. Print hello. There it is. Oh, I think it's going to be... So it gets in there at 0 milliseconds. I'm sure it'll be allowed back on the call stack before long. Who knows? All right. Happy. I'm just like... You can imagine people, I'm just like, I hope I can track all the stuff that's happening. I'm happy. So we've now finished with this line's work in JavaScript in completion. And so we hit our next line of JavaScript. At about 1 millisecond, but really it's faster, but just in order, we're going to hit the most pain in the ass complex 5 letters, powerful 5 letters in JavaScript. Let's go to Joe. Left-hand side, what am I declaring?
A function definition, or a const of a variable future data.
Perfect. And on the right-hand side, what am I calling?
Fetch.
Absolutely. With
a passing a parameter of
an argument.
String.
Yep.
Yeah, an argument with a string that contains a domain and a route.
Perfect. This fetch, people, does it do
two main things?
Exactly. It has a consequence in the web browser. Let's start with that one. It's going to kick off work by which web browser feature?
It is going to use fetch.
Well, I wouldn't say it's going to use
network.
It's going to use a network request feature. Yeah, exactly. Yes, it's going to use the network to do a request. And what information do we get for that request?
Yeah, we have the domain and the route.
Yep.
And we will implicitly be sending a GET.
Yeah, I like that. Exactly. It's going to automatically go to a GET request. There's our route, our path, and it's going to automatically be saying, go get some data, which at 1 millisecond, it does, off it goes to TikTok. And it sends an HTTP message saying, excuse me, I need to get some data. And it sends that at roughly 1 millisecond. And it wants to get whatever the cute puppy video is that I've uploaded to my TikTok at that path, at the /will. Okay.
Now it's also
link
marker time.
Give me one. You're right. But first, no, you're so right, Joe. But because it's got so much going on, let's also just check at 1 millisecond, is this work complete?
No.
Absolutely not. Lots of work to do there. But on completion, well, as you say, we're going to need to get our other consequence from fetch, which is what?
We're spinning up a promise object.
Yes, exactly. We're creating a promise object that is going to be stored into future data.
It is holding result.
Exactly. It's got some hidden properties on it. Result, undefined for now, and then this...
Then that array, the fulfill reaction.
Exactly. Fulfill reactions, but we'll just put fulfill for now, which is going to be an empty array into which we can store all and any functions that we want to have run when result gets automatically updated, because on completion, our network request in the web browser is going to have a reference to that object that was created at the same time from the two-prong fetch that is now stored in future data. Our immediate output from the call of fetch has to be a live thing. It can't be a go do some work on the internet. And that live thing is this special promise object with its hidden properties, which we can see in the console, but result, which is undefined, and the fulfilled reactions array, which we as yet have nothing in. On completion of that background work, what is going to be updated back in JavaScript memory, Joe?
We'll get the data, so the result.
Exactly. Future data dot result exactly will be set to whatever data we get back from speaking to TikTok. Excellent. Let's give Joe a hand. Very good from Joe. Deserving of a hand. People, everything we've done here has all been a result of these 5 letters. Have I missed anything on what fetch does there? I'm asking somewhat literally and somewhat rhetorically. Hopefully I haven't. But we do know we want to have some code run on the completion of that background network request and on the update of our result. Because, I sort of missed this. We know that as soon as this result property is filled with actual data, any functions in here will automatically be called, and their input will be that data. So we need to add some functions there. And we can't push into a hidden property with an array on it. We can't push into that directly. So we get a built-in method available on future data. Joe, what is that method?
So we're on the next line in global now, right?
Yep.
In which we're calling .then.
Exactly. And that gives us access to this array. And we're passing what function to that array?
Display.
The display
function definition.
Function, which we hope we've defined with a placeholder in it, ready to receive the data that will automatically be inserted in it when it gets executed automatically by JavaScript later on. Let's hope. Did we?
But we're not running it now.
We're not running it now, but we did include a parameter data ready to be filled in and used. So this grabs our display function, which, as you say, Key point from Joe there. We are not running that display function now. I don't even love the term then. Then should be called instead something like add this function to run later. Because I think that then in a sense implies we're doing it right there and then. Or you could say it doesn't, I don't know. But to me, what we're doing there, or what we are literally doing, is grabbing that display function and saying, on future data, when the data returns, you can then run that function. So essentially add our display function to this fulfilled reactions array. And that is where display will now be stored. So we can sort of show that as, I guess we can show it here, right? It gets stored into that array. All right, good stuff, people. Now we have done all of our background work setup, I think it's fair to say. And so now in our synchronous JavaScript thread, we hit what line after assigning or after attaching our display function using then. Tenzin, we hit what line in JavaScript?
I believe it's the block for
300 milliseconds. Exactly. And this, people, is a regular old function, so it's a brand new what, Tenzin?
execution context.
Execution context. It's going to be added to the call stack. There it is. Block for 300 milliseconds. And into it we go for 300 milliseconds. Do I want to go, so 300, 301, 302, 3, 4. Yeah, I think I'm going to say, so at 2 milliseconds, I guess, I guess it's the next thing in line. We're going to go inside block for 300 milliseconds that is going to run there in JavaScript for 300 milliseconds via a loop or some other thing where we're doing lots of small tasks for a very long time. That's the only way we can block in thread. While we're in there, well, actually, sorry, I feel very bad. Print hello. Feel so bad for print hello. Was print hello allowed back on the call stack before we ran block for 300 milliseconds?
Event loop says no.
Event loop says no, exactly. Almost a reference to a famous British comedy. Exactly, it was not allowed back on at 2 milliseconds. No, instead we hit our block for 300 milliseconds. I'm so sorry I assumed that. Like actually, print hello is like, excuse me, I want to come back on, but is it allowed? Event loop says no, because there's still synchronous global code to run. And now there's something on the call stack, so event loop continues to say no. But while this foreground work in JavaScript is happening, you won't believe what's happening back in our web browser. But at about 270 milliseconds, what comes back but our response data from TikTok. Now in practice, this data will come back and we'll need to do some JSON parsing on it to extract the actual thing we want, not the headers, or if we want the headers. But we're just going to keep it fairly simple. Well, firstly, at 270 milliseconds, therefore, we have completed. I should have asked. Have you completed? Yes. Yes, exactly. And what data do we get back? Well, we actually got a bunch of information about the request, the headers, information about about TikTok server, other background info, but in practice, we're just going to make use here for now of the name of our favorite latest video, which is going to be our cute puppies that we're going to do in purple. Cute puppy. There it is. Our cute puppy string. That's what we got back, the name of our most recent favorite video. And at that moment, what happens? We're in the middle of block for 300 milliseconds. At that moment, we can update our future data result. I'm going to add a caveat for that in a moment. But for now, at that moment, we now have our data back. What do we do on completion? At 270 milliseconds, we are going to update our future data result value with our cute puppy. There it is, our cute puppy. Okay, which means our display function is ready to go. Hooray! Where will it be queued up, people?
Callback queue.
Of course, well done. You're all going to be completely wrong, but yes, where else would it go? Into the callback queue. Let's put it there. Ready, behind print hello. It was added there at 270 milliseconds. There it is. And because display is now ready to run, right? Because the result value came in and display auto runs, ready to go, but it can't go on the callback queue immediately because we're still stuck here. We're at 270 milliseconds. We're in the middle of the block for 300 milliseconds still. We got two things in the queue. We are finished with running for blocks for 300 milliseconds. We're outside of it now. We hit 302 milliseconds. We pop block for 300 milliseconds off the call stack. And what do we hit as our next task? Well, presumably, we go to our callback queue. No. Well done, everyone. Where do we go first, Chris?
Console.log.
Console.log me first. Good old me first. At least it gave us a clue with its name. And therefore, at 302 milliseconds, we got our me first in our console. Okay. But now we hit our 303 milliseconds in JavaScript. And now I assume our poor print hello that was set to run after 0 milliseconds all the way back at the top here, now it gets to go on the call stack. Right, everybody?
Yes.
Should be right. And yet, in fact, display gets to go on the call stack first with our input of cute puppy. Cute puppy. Poor old print hello. What is going on here? I'm going to decide what I'm going to say in a second. Display pass in cute puppy. There it is. And what does display do? A brand new everyone together.
Execution
context. Beautiful. Into it we go, where our data parameter on display, Chris, is given what argument automatically. Notice JavaScript added those parens. We didn't add those parens. When we passed display into futuredata.then, we just say the definition. But when it's called, it automatically adds parens and automatically puts the input of the data in. So what is our argument, cute puppy, going to be assigned to inside of the data call?
To data.
To data. Perfect. And there it is. Data is cute puppy in our local memory. And we console log data, which is to say at 303 milliseconds, we console log cute puppy. But this makes no sense. I know how a queue works. I take the first thing in. Is that right? Yeah, the first thing in is the first thing out. That's right, isn't it? Yeah. The first thing in is the first thing out, not the last thing. Can anyone make an intuitive guess at where or what might have actually happened here? Where do we think display might have actually been added, if not? Well, okay. Anyone make a guess? Chris, you want to give a guess?
A different queue.
Let's give him a hand. Well done, Chris. An incisive insight from Chris. People, the callback queue, sometimes known as a task queue, is just one, at least within the web browser, of our two important queues. We have a second queue, the microtask queue. And into that goes all functions that are deferred, to be run later, by being added to promise objects. They never go into the callback queue. Display never went in there. Display went into the microtask queue. There it is, into the microtask queue at its completion of 270 milliseconds when our data came back and the display function was added to our queue at 270 milliseconds. There it is in the microtask queue. And what might you think the event loop prioritizes as its queue to always check first, Chris?
The microtask.
The microtask queue always gets that priority. We always check it first. So when the event loop saw that we had finished running global code with our console log me first at 303 milliseconds, it did not go to the callback queue where print hello had been sitting since 0 milliseconds, since the very start, and went, check the microtask queue where display had just rocked up only 33 milliseconds earlier, and it said, don't panic, you're my priority, and it grabbed display, put it on the call stack, passed in our cute puppy data as our argument, and there we had a new execution context and displayed cute puppy. At which point, display was now no longer in the microtask queue, was popped off the call stack, and finally, at 304 milliseconds, what do we think the event loop, Chris, finally said, I'm going to look at you and give you some time?
Print hello.
Print hello. And print hello was added to our call stack at 304 milliseconds, when it had hoped to be run at after 0 milliseconds. It had to wait all the way through until 304 milliseconds when print hello was finally executed, and what, therefore, Chris, at 304 milliseconds was displayed in our console.
Hello.
Hello. Oh my goodness. For one thing, by the way, I gotta say, John is going to love our beautiful, colorful blackboard here. But, wow, it turns out that we don't just have one queue. And our promises, our promise deferred functionality attached to a promise to only be run automatically when some background work completes and the value property is updated, it gets precedence. It gets put into a separate queue known as the microtask queue. And that queue is checked first by the event loop as it does its checks every time. Is global finish, is global finish, is global finish? It is. Don't go first to the callback queue, go first to the microtask queue, which is where display, by being promise object deferred, was being queued. Once that was done, now finally, JavaScript's engine, the event loop checked our callback. I do want to just add one, summary of this, but also add one more thing as a bonus. So, promises, what are our problems with these? Well, most developers do not know how they're working under the hood. Without a shadow of a doubt, most people think that there's some sort of running of that function display at the moment when it's passed to then. Instead, much as before, we set up background work with fetch, we store an object in JavaScript that is associated with that background work, to which we can then attach a function that will only run when that background work completes, and that function is then populated, its input, its argument is populated with the associated data that we retrieved. So therefore, debugging becomes super hard with these promise objects. And developers fail technical interviews. How about that? That's setting up the problem. Our benefits of the promise style: cleaner, readable code that has a pseudo-synchronous style. Rather than as before with our set timeout, where we pass in a function definition that we know is going to run way later. Here, by the way, we're still passing in a function definition that we know is going to run way later, but at least we're passing it in after the word then. I don't know. And it has a really nice error handling process. Suppose instead of getting back cute puppy, we instead got back some error. Maybe we have some error, we didn't get a response from the server. Maybe instead we had some error saying you're not allowed access to this adorable video. Our promise style very helpfully gives us a tool to handle that error. And that is an additional array on our future data promise object, reject reactions. Reject reactions, also hidden, is another array into which we can attach functions we want to have run on an error being returned and assigned to this result property. If we instead get an error here, it will automatically not run the fulfilled array, but the rejected. And the functions in there we can then write such as to handle the error. How do we attach the functions to that array? Does anybody know? We don't use .then. Does anybody know what we attach? Yes, Michael?
Catch.
.catch, exactly. Rather than .then, we would run .catch and pass in our function to have run automatically with our error. And there's one more thing I do want to add. I probably shouldn't put this. Let's have a look. We have rules for the execution of our. Okay. We have rules for the execution of our asynchronously delayed code. Hold our promise deferred functions. We've said this all right in the microtask queue, and callback functions, the ones past the old school stuff like set timeout, in the callback queue. When the web browser API finishes, they go into those queues. Only add the function to the call stack, i.e. run it. When the call stack is empty, all global code is run. Have the event loop be checking that all the time? Prioritize functions in the microtask queue over the callback queue. Before we get to our summary, I want to add one more thing that I will try and keep tight, but it's just a fun new thing that was added 2 years after Fetch was introduced, which I do think is quite entertaining. And that was the ability to abort a fetch background task when we have some information, a timeout, something that determines we don't want to keep it going. We don't want to wait for a response because the server may never give us a response, but instead abort it. And that is using this abort signal approach. It allows us to pass in, and I'm going to try and keep this fairly tight. I want to show here that we can pass in as a second input an object. Now, this object could also have the property of whether we're going to be getting or posting or otherwise, but we're just going to use its property signal to which we are going to attach, and let's declare the only line we've added here that was added in, oh wow, actually this bit, the abort signal timeout was added in 2022. The ability to abort, to pause background work was added in 2017, but this particular one, there's a timeout-based signal, was added in 2022. So let's squeeze this code in here. We're going to declare signal, and it is going to be the result of calling this built-in feature abort signal. Built-in, we didn't define that ourselves. Built-in, calling the timeout method on it, and it is going to actually also act as two-pronged. Within JavaScript, it's going to return an object that has on it the property aborted, and it has on it the property reason. And these actually aren't hidden properties. These are properties we can see. And the aborted is initially undefined, and the aborted is initially false, and the reason is initially undefined. Okay, this object we can pass in to our fetch when we first set up our background work speaking to the internet and our promise object. We can pass it in there. We don't need to show the details, but we can pass in that signal object that we just defined here. It is going to modify the behavior of our network request. As soon as we define that signal, it had two consequences. One, it created an object in JavaScript, and two, we've run out of space. Two, it set up in the background, what do you think? It's a countdown. What do you think it set up, Chris?
Timer.
A timer. Exactly. A timer in the background. For how long, Chris? 200 milliseconds. I don't think we're going to... Well, when do we set this up? 1 millisecond. So at 1 millisecond, that timer was obviously not complete. See, I'm trying not to go too detailed on this, but obviously not complete. But immediately after, we passed in the object that was connected to that timer to fetch. And you know what that did? It set up a bond in that network request in the background in the web browser to that timer, such that if that timer completes, ensure that we abort, we cancel the background network work, and instead return an error. And as it happens, we saw that at 270 milliseconds, we got our response. But if we'd had this background timer passed in with the abort signal, with the 200 milliseconds timer, well, I would say then at 201 milliseconds, it would have completed. And what would that have done to our network request, our background work? It would have said, I don't know which color to use here. Oh, orange for error. It would have said, error, not cute puppy. We would have never reached our cute puppy response. And our error would have been passed in to our result, and we would have had error here instead, meaning would we have called our fulfilled array functions? Nope. Exactly, Michael, we'd have jumped straight to our reject ones, where you can see I wrote .catch to add to the reject one, actually just the same display function. Probably should have written an error handling function, but to be fair, I displayed our error, known as a timeout error. And our forefront object here would have been transformed to true, it was aborted, and the reason being a timeout error. But people, this is just a bonus thing to see the control we have, and then once we have our mental model, we can see where this activity is happening, and the control we have now over our background work with the all-powerful fetch. We can even set on fetch a connection between one background task, speaking to the internet, and another one, a timer. And set that if that timer is completed before the background, speaking to the internet, completes, then return from that background network request into the promise object an error, not instead our response, cute puppy. So people, promises, web APIs, callback, microtask queue, and the event loop all enable us to build non-blocking applications. We were able to plow straight on from these two rather demanding background tasks. Well, not this one, 0 milliseconds, but it could have been 1,000. Our call to fetch are all happening, our call to fetch, which triggers a network response, the network, the timer, any stuff that could take time, even short time, because it could have been longer, happens in the background. It means we don't have to wait in our single JavaScript thread and don't block further code from running. We set up our background timer, we set up our speak to the internet, and yet we could then still hit our block for 300 milliseconds, we can still hit our console log, me first. However long it takes, because we can't predict when our background work will complete. Much of it, not a timer of course, but much of it, like speaking to the internet, we don't know when it's going to come back. So we let JavaScript handle automatically the running of the function on completion. We do not say, wait in here until you get the data back, we don't know how long it could be, then run it. Nor do we say, nor do we try and time it. Put the parens on at the moment when the data comes back. Rely on JavaScript to automatically add our parens, and insert the data that came back automatically for us. I didn't see parens anywhere here on display. I didn't see parens anywhere here on print hello. Instead, we passed them into these facade functions and relied that when they came back into JavaScript, JavaScript added parens for us. And even in the case of display, inserted the data that came back automatically. This allows us, people, to build the modern web applications we are so experienced with. The asynchronous JavaScript the natures of JavaScript being asynchronous is the backbone of the modern web and lets us build these fast, non-blocking applications. What we know as single thread is in fact a single thread in JavaScript and a whole bunch of background work behind the scenes.